Welcome back, grade 12s. Now, let us move on to the calculations involving future value annuities. Now, the future value annuity formula is as follows. It's F is equals to X open bracket 1 plus I all raised to the power n minus 1 close the bracket all over I. Now, in this case, F, it represents our future value. X is the regular payment that we make. I is our interest rate, and N is the number of payments that we are making. Now, example number 1. Now, in this example, we are told that Mokheseng opens a savings account and immediately deposits 500. After this, he continued to deposit 500 at the end of each month for 4 years at an interest rate of 8% per annum compounded monthly. How much will he have at the end of 4 years? Now, this information, we will now populate it in our timeline. Now, let us see. They're saying Mokheseng opens a savings account immediately and deposits 500. So that 500 in this case is our X. So our X in this case is 500, and he continues to deposit 500 at the end of each and every month for 4 years. So we have our period is for 4 years at an interest rate of 8% per annum compounded monthly. How much will he have at the end of 4 years? Remember, we are saying when you're talking about annuities in our timeline, T1, T0, T3, whatsoever, those are representing our compounding periods. Now, when you say it's compounding period, that is to say it's from T0. Now, this is the end of our term, which is 4 years. However, remember our T1, T0 to T48. Why T48? We got T48 from saying our N is equals to, we are told that it's 4 times 12, which is the 48 that we get in. Because remember now, N in this case, it is no longer representing the period as it did on our previous example or on our baseline activity from grade 11. So N in this case now represents what? The number of payments. So we are making a payment monthly for 4 years. Then how many payments are those? Those are 48 payments in total. Now we are saying he deposit immediately. That's why the first deposit of plus 500, it is made immediately. And we're going to deposit from that to say 500 T1, 500 T2, 500 T3, 500 until T48. Then we can see that we'll deposit until the end of our period or the end of our term. Now, what do we now get using the formula now? Now, first thing that we do in this case, we now quote the formula down. Remember, we are now working with annuities. So in this case, what we'll do is the following. Number 1, so in this case, we quote down the formula of an annuity. Thereafter, we substitute into this formula to say our F is what I'm looking for. So we are looking for a certain amount at the end of period. So F, it remains unknown because we are looking for F. Then we proceed to say, okay, now in the space of X, what do we substitute? We now substitute how much? 500, because that is the amount that I am making monthly into my account. Then we proceed. We are saying open bracket, open another bracket, 1 plus I. Our I in this case, remember, with annuities, the I is not changing. So our I in this case was 0.08. As we divide this by 100, divide by the compounding period. What is our compounding period? It was compounded monthly. So divide by 12. So our I there is 0.08 over 12. All raised to the power 48, which is the number of payments, minus 1 all over I, as our I is 0.08 all over 12. Now we punch everything as it is in our calculator. we get our future value as 28,174.96. So that is the amount we get at the end of 4 years from depositing 500 rands per month. Now, if I were just to highlight something, remember, we are saying under annuities, the amount that you deposit or the regular payments, they must correspond with the compounding period, and they are corresponding here. As you can see, it's 500 at the end of each month, and it is compounded how? Monthly. Right. Now, I'm going to give you 2 minutes to complete the following activity. Welcome back, grade 12s. Now let us discuss the solutions to this activity. Now, under this activity, we are told that Lewood decides to save 200 rands per month for the next 3 years to create an emergency fund for unforeseen expenses. She makes the first deposit immediately and the last deposit at the end of 3 years. The interest rate is calculated at 8.7% per annum, compounded monthly. How much will she have saved up by the end of a 3-year period? Now, remember, when we are looking at finance questions, first thing, we quote down the timeline. That means you collect the data onto or in our timeline. So what do we do now? We say Lewood decides to save 200 rands. So our X is 200 for the next 3 years. So from T0 until T36, we'll explain T36 now. To create an emergency fund for the unforeseen circumstances, she makes the first deposit immediately and the last deposit at the end of 3 years. So the first deposit is made immediately. So at T0, we are putting in how much? We are putting in 200 rands. Now, and the other one is made at the end of 3 years. So at the end of our period, we are still putting in the 200 rands there. The interest rate is calculated as, so our I in this case is 0.087 divided by 12. Where do we get that? Remember, it was given as a rate. We divide that by 100 to get it as I, which is 0.087. And where we have a compounding period, what do we do? Our I must be divided by that compounding period. As it is monthly, then our I is divided by 12. Then we proceed to say, how much will she have saved after at the end of a 3 year? What is our N now? And N is 3 times, because remember, N is no longer the period. It represents the number of payments. Now, how many payments did he make? He made payments for 3 years. How often? Monthly. That means it was compounded monthly. So it is 3 times 12, which is 36, which is our T36 there, to represent the number of payments made from T0. Thereafter, what we do? We now quote down the formula, because he wants to, or she wants to do what? She wants to save for the future, for the unforeseen expenses in the future. So we are using the future value formula. We quote it down. We substitute into the formula to say, in the space of X, F is our unknown. We are looking for F. So we want to know how much will she have at the end of 3 years. It's equals to, in the space of X, so our X, she's making a monthly deposit of 200. We put 200, open bracket, open another bracket, 1 plus I, our I, as we have calculated it there. It's I, which is 0.87 divided by 12, all raised to 36. The 36 there, it represents what? The number of payments that she has made. Minus 1 all over I, which is 0.087 over 12. We plug everything in our formula. Then our future value is 193.27. Right. Let us look at example number 2 on annuities. Now, on this example, we are told that David wants to save 1 million by his 30th birthday. Okay. On his 18th birthday, he opens a savings account that he makes equal monthly payments into the account, starting 1 month after his account was opened, and this is important, starting 1 month after, and the last payment is made on his 30th birthday, and the account pays the interest of 15% per annum compounded monthly. How much money will he have to save each month to reach his goal by his 30th birthday? Now, let us look at this one. We are told that David wants to save 1 million. So what are we doing? We need to populate this in our timeline. Number one, David wants to save 1 million. So David wants to have 1 million rands in future. When is that future? On his 30th birthday. Now we're saying our future amount in this case is 1 million rands. By his 30th birthday, okay, on the 18th birthday. So you need to check. We are given days there. We are not necessarily given a certain period. So what are we supposed to do? We need to find the period. That is to say, how many years? It is from 18 to 30. So from 18th birthday until 30, how many years will that be? We'll now say, okay, to get our n, we'll say from 30 minus 18, what do we get? We get 12. Now 12, it is the years from 18 until 30. So he has 12 years to actually save up to 1 million. Now remember, our n represents number of payments, and how often is he saving? He's actually making equal monthly payment. So this is compounded monthly. So we'll even see with the interest there, it says compounded monthly. So 12 times 12, we get 144. So the 144 there represents our what? The 144 represents the number of payments that he will make from his 18th to 30th birthday. Now we proceed. Starting 1 month, 1 month after, so we can see at T0 we have nothing. We don't have an X there. The X is at T1 because we started a month later. Remember, this represents a single compounding period. As it is compounded monthly, so a month later will be at T1, right? So to start 1 month after his account was opened, and the last payment is made on the day, so it is made on the last day. Now the account pays the interest, so our interest in this case I is equals to 0.15. As we take the rate, we divide it by 100 all over the compounding period of 12. Then how much money will she have to save each month? So we are looking for X. So X there is our unknown. So we need to find out how much we need to save up to this. Now let's proceed. We quote down the formula. So we are saving for the future. So we are quoting down the future value formula. We substituting to the formula. We are told that we have the future value because we want to save up to 1 million. So in a space of F, we place in 1 million. X is unknown, it remains as X. Open bracket 1 plus our I there as it is quoted is 0.15 divided by the compounding period of 12 all raised to the power 144, which is the amount or number of payment that he will make, minus 1 all over 0.15 all over 12. Then we solve that and we get our X as 2508.77. Now to calculate the X there, just to give a clue, so this is how we will find the X. We'll actually take 1 million, multiply by that and divide by everything that is on the bracket there. That's how we're gonna get an X. That is to say, we'll say X is equals to 1 million times 0.15 over 12 all over, we divide by everything that is here. So we cross multiply here, this multiplies that, it's no longer there, then we divide by the whole thing. So we're saying 1 minus 1 plus 0.15 in all over 12 to the power 144 minus 1. So we make that calculation, that is to say, we press as it is in our calculator so that we can get an accurate value. So to get x there, what we do, cross multiply. After we cross multiply, what we do, we divide by whatever that is on our or in our bracket, which is what we have there. Right, then we get x as that amount. So I will give you 2 minutes to complete this activity. Right, welcome back, grade 12. Now let us discuss the solutions to this activity. We are told that Amatha wants to save up 100,000 to pay a deposit on a house in 4 years' time. She makes equal quarterly payments into savings account starting immediately, and she makes the last payment at the end of the years, which is 4 years. How much must she save each and every quarter to get that amount if the interest is calculated at 12% per annum compounded quarterly? Remember, we are working with finance. We collect our data. In this case, we are utilizing our timeline. We are saying, I'm actually want to save up 100,000. So the 100,000 there is the money that I want to accumulate in future. So that becomes our future value. To pay a deposit on a house in 4 years time. So the period there, we have n, our n there, it's equals to 4 years. Now she makes equal quarterly payment. Remember, n represents number of payments. So the period is 4 multiplied by the compounding period, which is another 4, which is 16. So that means we are moving from T0 to T16. Hence we have the T16 there. And they're saying starting immediately. So the first deposit is made at T0, and the last payment it is made where at the end of 4 years. How much must she save each quarter if the interest rate is calculated? So our interest rate, we are told that we are given that as a percentage. We convert that, we get 0.12 by dividing this by 100, the 12% by 100, all over the compounding period, which is quarterly. Quarterly means divide by 4. Now that we have all the information we need, we quote down the formula. Remember, we want to save up for the future, so we are utilizing the future value formula. We quote it down. Now on our future value formula, what do? We substitute the given values. We have future value as 100,000. We don't have x, so we're calculating for that x. It remains as unknown. Open bracket, open another bracket. 1 plus our I then divided by the compounding period, which is 0.12 to the quarterly compounding period of 4 divided by 4 raised to the power 16. As we are making the total payments that are 16 minus 1 all over I. Our I there is 0.12 divided by 4. Then we solve for x there. Remember, when you solve for x here, we cross multiply. So it's going to be 100,000 multiplied by 0.12 all over everything that is on this bracket, as we did on the previous activity or example. Then we punch everything in our calculator. We get our x. Then we know that Amathe, in order for her to get 100,000, she must save up a 4,961.08 rands quarterly. So after every 3 months, we put in 4,961.08. Present value annuities. We have talked about future value, where we are going into the future. Now, let us discuss a situation whereby the amount it is given to you right now. So let's see what happens now. The present value formula is used whenever the total amount is paid or received first. Very important. So this one we applied most when it comes to loans, because we receive the amount first and we make regular payment later. What are these regular payments? These are actually repayments, just to add there. So we are repaying the amount that was given to you in the present. So you are given a certain amount first, then you will be expected to repay that amount as it was loaned to you. We are saying the total amount is paid and received one interval before the first payment. That's what we are saying. We are saying the bank will give you money, will loan you money today or this month. They won't expect you to pay the money immediately. You will pay the money a month later. It is used when the sum of money is set aside. Also, it is also used when the sum of money is set aside in order to make regular withdrawals in the future. This is to say, it's present. So I have maybe 10,000. I want to take the 10,000 and I put it away in such a way that I'm going to make it my living amount, whereby I will withdraw certain amount monthly from that 10,000. That is present value, because I had the 10,000 initially. Then we are going to withdraw money monthly, or maybe I'm going to withdraw it quarterly, depending on what I want. Now, let us talk about present value formula. Normal situation. There must be a gap between when you are given the money and the first repayment. What is the purpose of that gap? In most cases, when the bank does that, they want the first payment to include the interest already. That is to say, when they give you money in the present, they will give it interest first. So if that money will receive the interest first before you can start making repayment on that amount. That means if they, let's say for example, they give you 300,000 immediately. Now, when they give you 300,000, they won't expect you to pay immediately, as they won't even tell you, they will tell you that next month when you start paying, you'll pay at this percentage, this much. So that is to say, you get 300,000 now. When you make the first payment, it is already maybe 305,000. So that's what normally happens. So we get the money, there is a gap. We don't pay immediately. We allow that money we gave to you to gain interest. Then we make the first payment when you already have gained interest. So that's why we have a gap between when we have deposited immediately and when we make our first payment. So that is the purpose of having a gap there, right? Remember, this is a present value annuity. What are we doing? We are coming back to the present. Why present? Because we received the money already. So we must repay back the money that we have in future. So we are coming back to the present amount that I have received. So that is to say, actually our X was supposed to go with a negative there. Why negative? To show you that it's a repayment into an amount that was received already. To add there, to say this X, it is reducing the amount that we had in the present with a certain value. Now, present value annuities, let us look at the formula. Now, this is the formula that we are utilizing. It's P is equals to X, open bracket 1 minus, open another bracket 1 plus I, all raised to the power negative N, close bracket all over I. Why negative N? Very interesting. We have a negative N because we are moving from the future, we are coming back to the present. So we are reversing, we are moving to the backward direction. That's why when we go back, when you go back to our timeline, you can see the timeline, the present value there is actually going back. We are collecting those payments from here to here. We are collecting it back to the present. That's what we are doing under present value annuities. So that's the purpose of having a negative N, to show you that we are reversing. P in this case is our present value. X, it is the repayment. So that is the payment that we are making regularly. I is our interest rate. N is the number of payments, again, not the period, in this case. Now, let us look at the example on the present value annuities. We are told that a Matthew takes out a loan of 175,000 at 18% per annum compounded quarterly. He repays the loan over the period of 4 years, starting 3 months after the loan was granted. Calculate Matthew's quarterly repayments. So, with this information, remember, we populate it in our timeline. So what are we told? Matthew takes out a loan of 175,000. So this loan is already given to him. So it's the present value. So Matthew was given 175,000 at T0 at 18% compounded per annum compounded quarterly. So our I in this case is 0.18. Why 0.18? Because it is quoted as a rate. We divide that by 100. So we divided it 18 by 100. Then we get 0.18. Then from that 0.18, what do we now do? We divide our I by our compounding period, which is 4. So we divide that I by 4. Then we say starting 3 months after the loan was granted. Why 3 months? Because it is quarterly. So this is a normal gap. So we have that gap we're talking about. And in this case, the gap is going to be 3 months. Because remember, our compounding period is quarterly. So that's why from here to here, it will be how many? It will be 3 months instead. So when it's monthly, from T0 to T1, it will be 1 month, for example. So our normal gap there, because our compounding period is quarterly, it's going to be the 3 months. So it's 1 quarter day. Calculate the quarterly repayments. So these are the repayments that we need to find. Now, how many repayments is she going to make? He's taking the loan for 4 years. So how many repayments will he make? It's 4 times. The compounding period is quarterly. Quarterly means multiply by 4, which is T16. So we're moving from 0 to T16 in that case. So what do we do? Because now I received the loan right now, I have the money present in the present. So what do? We quote down the present value formula. We substitute into the formula where we're saying in a space of P, what do we put? 175,000, which is the money received. It's equals to X. X, it remains as an X as it is our unknown. Open bracket 1 minus 1 plus 0.18, which is I divided by 4, which is our compounding period, all raised to the power negative 16, to show you that we are going back to the present. That's what we are doing then. All over 0.18 over 4. Then we solve for X there. We get X as 15,577,69. This is easy to say. When you find X there, remember, this is how we do it. We're saying cross multiply first. Where we'll have X is equals to cross multiply the 2. We'll have 175,000 multiplied by 0.18 over 4, all divided by everything that is on this, that is in this bracket. So all divided by 1 minus 1 plus 0.18 all over 4 to the power negative 16. So we press everything as it is there in our calculator. We get the value of X as 15,577.69. So you will be given 2 minutes to complete this activity. Right, welcome back, grade 12. Now, let us discuss the solutions to this activity. The activity says Simon wishes to purchase a car for 80,000. If he borrows money at an interest rate of 8.5% per annum compounded monthly, calculate the monthly installments. Is the loan to be paid back over 5 years? Right, so we are told that Simon wishes to purchase a car. So that is to say, the car costs 80,000. That means Simon took the loan of 80,000. We will populate this information in our timeline. When we populate that information, we are saying P, it's 80,000. P is 80,000, as Simon will make a loan of 80,000 because that is the cost price of that car that he wants to purchase in the present. So the present value in this case is 80,000. The money that he borrowed is at an interest rate. Our I in this case is how much? It's 0,085. That is to say, we take 8,5, we divide that by 100. All over, we have a compounding period there, which is monthly. So all over 12. They said calculate the monthly installment. So we need to find the monthly installment, but we need to know how many installments will he make. So we're saying it is over the period of 5 years multiplied by the compounding period, which is 12. So 5 times 12 there, we get 60. So that means T0 in the present, it is 80,000, and the last repayment will be made after 5 years, which is at T60. So you will make equal payment of up to 60 payments. Now remember, this is present value. We are going back to the present. So what I will say, we quote down the present value formula. As Simon received the loan of 80,000 to get the car of 80,000, he will have to repay that loan of 80,000 monthly as he lives or as time goes by. We now substitute into the formula in the space of P. So in the space of P, what do we now have then? P is given as 80,000. So we substitute P with 80,000. Then X, we open bracket 1 minus into 1 plus. Our I is 0,085 all over 12. All raised to the power negative 60. 60 is the number of payments, which is the 8060. All over 0,085 divided by 12. Then we solve for X by cross multiplying that and that and dividing by the whole bracket as discussed in the previous slide. Then we get X as 1,641,32. So that is the amount that Simon will pay monthly to repay the loan of 80,000. Now let's look at the fourth example. Now present value annuities again. Let's see. In this example, we are told that Tabo can afford to pay 8,000 per month on a car loan. If the interest rate is charged on a car loan is 15% per annum, calculate, or the first payment is made 1 month from now, which is a normal situation, and will repay the loan over the period of 5 years. Calculate the price of the car that Tabo can afford. So now, what do? We populate everything in our timeline. Remember now, we do not have the money. So Tabo can afford a certain amount, but we need to know how much present value will he have by paying 8,000 per month. So the repayments that we're having is 8,000 there. For how long? For 60 payments. We're making the 60 payments. So our N in this case, it will be, so we can say it's 5 years, which is our period, times the compounding period, which is 12, which is 60. 5 times 12 gives us 60. Now, so these are the monthly repayment on a car loan. The interest rate is charged at 15%. So our I is 0,15. We divide that 15% as a rate by 100 all over 12. What is this 12 for? The 12 is for the compounding period. Then we continue to say calculate the price that of the car that Tabo can afford. So we're looking for the present value because he wants the car now, so it's present value. We quote down the present value formula. We substitute into the formula to say in a space of X is 8,000 because that's the amount that he can afford to pay monthly. Into 1 minus open bracket 1 plus 0,15, which is our I over 12, which is our compounding period, all raised to the power negative 60, close bracket, all over I divided by a compounding period. We punch everything as it is there in a calculator. Then we get our present value is 336,276.73. That is to say, the car that Chabo can afford will cost 336,276.73. This is actually a typical example to say, if you want to buy a car and you know your budget is maybe I can save 8,000 per month, then you know what kind of a car you can think of, or you can compare it to say, if I take this car, Toyota of this much and a Suzuki of this much, which one can I afford? So this is actually a practical example to say, I have a budget of 8,000, I can only afford 8,000 per month. Then which car will I be able to purchase when I look at my budget? This is one of the ways that you can do it. Now, I will give you 2 minutes to complete this activity. Right, welcome back, grade 12. Now, let us look at the activity that was given to us. The activity says, auto repays a loan over a period of 5 years by means of equal semi-annual payments of 15,000, starting 6 months from after the loan was granted. What is the value of the loan if the interest rate is 14.8% per annum compounded semi-annual? Number one, we are saying auto repays a loan over a period of 5 years. Very important. So, by the means of a semi-annual repayments of 15,000, starting 6 months after the loan was granted. So, this is also important. What is the value of the loan if the interest rate is? So, as you can see, what I'm doing here, I'm underlining the important information or details that are in our statement. These are the details I'm going to populate in my timeline. So what do we do? So we are told that auto repays a loan over a period of 5 years. So N, we have 5 multiplied by the compounding period. What is the compounding period in this case? It is semi-annual. Semi-annual means multiplied by 2. So 5 times 2 give us 10. So we are going from T0 up to T10. Now, starting 6 months after the loan was paid, so that's our normal gap. Because this is a semi-annual, so one semi-annual day is 6 months. Now, we have a normal gap there. What is the value of the loan? So we are looking to know how much is the loan. So in this case, we are looking for the present value. Our interest is charged as, we have 14.8. We divide that by 100 as it is given as a percentage to get 0.148 divided by the compounding period, which is semi-annual, which is divided by 2 in that case. Now, the repayment that he's making is 15,000. So that's why we have the 15,000 with a negative to show that we are repaying the amount that was given to us already. Now, this is a loan. So we are saying the loan was given to you, it was granted, and we give it to you immediately. So we quote the present value formula. Then we substitute into the formula to say P is unknown. We are looking for that P. X is the monthly repayment. So we have our X as 15,000, open bracket 1 minus, open bracket 1 plus. Our I is 0.148 all over 2. The 2 there is our compounding period. All raised to the power negative 10. The negative 10 is the number of repayments or number of payment, which is our N, all over I, which is 0.148 divided by 2. We punch everything in our calculator. We get the present value as 103,432.999. So that is all. Now, so grade 12 will be given 10 minutes to complete this activity. So it's in 2 parts. So number 1, number 2, I'll give you 5 minutes to complete this. Now, let us discuss the solutions to this activity that was given to us. Now, welcome back to 12. Let's look at this. Now, we are told that Steve plans to save 1 million in 15 years. He makes monthly deposit of into the account, paying an interest rate of 14% per annum, compounded monthly. Calculate his monthly repayments. So what are we doing? So he plans to save 1 million. So we are going into the future. So our future value there is 1 million. For how long? For 15 years. So number of payments will be 15 multiplied by compounding period, which is monthly. We get 180. He makes the deposit into an account at an interest rate. So our I, we have 14 there. So it's say 14 divided by 100, which is 0.14, all over compounding period, which is monthly, divided by 12. They say calculate his monthly repayments. We are now told that he's making the deposit immediately and the last one at the end of T180 there. Even if this is not stated, we are making that assumption when it is not stated. When it is stated otherwise, then it will fall under deferred annuities. We'll discuss later. However, nothing stated, we make an assumption that it was immediately and the next one was paid after a certain period. Now calculate his monthly repayment. So we want to saving some amount for the future. We call the future value formula. We substitute into the formula. In a space of F, we put 1 million. X is our known, we put it as X into 1 plus I is 0.14 divided by 12, which is the compounding period, all raised to the power 180, which is the total number of payments minus 1, all over I over the compounding period. We solve for X there, we get X as 1650.75. Now let us look at number 2. So on the second activity, we are told that Gift wants to move out of his parents' house when he's done with the school. He decides to save 2,500 per quarter for the next 2 years, starting immediately. So the first payment is made at T0 and the last ending at 2 years. So the last one is made at the end. How much will he have saved up by the end of 2 years if the interest is calculated at 9% compounded quarterly? So we are saying our N in this case is gonna be we are looking for 2 years, the period of 2 years. Total number of payments will be 2 times compounded quarterly means multiplied by 4, which is 2 times 4 equals to 8. Then our I, we're collecting the data. Our I is 0.09 because 0.09 is 9% divided by 100 already. Divide by now the compounding period, which is 4. Then we are calculating, we are looking for the future value. So what is the future value? We quote down the future value formula. We substitute into the formula to say F is equals to X, the amount that we paid per month is 2,500. F is our known, so we put it as F, open bracket 1 plus I is 0.09 divided by 4, which is our compounding period, all raised to the power 8, which is the total number of payments, minus 1 all over 0.09 over 4, which is the compounding period. Then our F is 21,647.9. Right, let's look at the last one there, number 3. So number 3 there, it says a loan of 50,000 is to be paid off by the 10 quarterly payments over 10 years. If the interest rate is charged at a rate of 10% per annum, compounded quarterly, calculate the value of the repayments. So we populate the whole information in our timeline. A loan of, so the 50,000, I received the loan of 50,000 is our present value. It's equals to 50,000 is to be paid off by equally quarterly payments over 10 years. So our number of payments, it's 10 years multiplied by the compounding, which is quarterly, times 4, which is 40. So our N is 40. That means we're going up to T40. If the interest is charged, so our interest rate is I, which is 0.1. That is 10% divided by 100 all over the compounding period, which is 4. They say calculate the value of the repayments we're looking for. I remember they didn't even also it was not mentioned to us also in this case. So we must understand that it's a normal one. So Hence, we'll actually have a normal gap there. So when we're not told anything in the statement, we're gonna just assume it's a normal present value formula. We substitute into the formula where P is 50,000, X remains unknown as we're looking for it. Open bracket 1 minus, open another bracket 1 plus 0,1, which is our I, divided by 4, which is compounding period all over. Or close bracket to the power -4 and close the bigger bracket over 0,1, which is our I over 4, which is our compounding period. Then what is an X? Then the X value is 1,991,81. That is the amount that we pay in that case. Now, let's look at number 4. So number 4, it says, Tando's monthly repayments on a student loan is 3,500 per month. She repays this loan over 4 years at an interest rate of 12.5 per annum compounded monthly. What is the value of Tando's student loan? So in this case, what do? Plot everything in our timeline. The repayment is 3,500. We represent that the loan over the period of 4 years. So our N is equals to, it's 4 multiplied by the compounding period. It is per month. So multiply by 12, we get 48 as our N at an interest rate. So our I will be 0,125 as we divide this by 100, which is 12.5 all over our compounding period of 12. Then we are saying, what is the value of the loan? So we are looking for the present value. What do we do now? We quote the present value formula. So the formula that we quote, we quote it down. After we quote down the present value formula, we substitute into the formula where we have 3,500, open bracket 1 minus 1 plus I, which is 0,125 all over 12, all raised to the power 48. We have a negative there because we're working with the present value formula, all divided by I, which is 0,125 all over 12. We press everything in the formula, we get our P as 131,667,96. So this is the homework, and we will discuss the solutions in our next lesson. Summary. So under this summary, what did we do? We dealt with, so under our summary, we dealt with the future value formula, where we're saying the regular payments are made first and the total amount is collected later. In this case, what are we saying? We pay immediately at T0 and we collect immediately at the end of or at the last payment. So that's what we are doing in this case. We use the formula as quoted there for the future value formula. For the present value, we are saying the total amount is paid first. So we receive the amount first. Thereafter, after paying the amount first, what do we now do? We make the regular repayment. So we pay present value, we receive the money, we repay after, and the total amount is paid. The total amount paid is received exactly one interval before. So that is to say, future value, what are we doing? We are making regular payments first, and those payments will be collected in future. Present value, we receive the money first, we repay the money that was given to us, and we start to repay that money under present value an interval after we receive the money. Right, review of the next lesson. So on the next lesson, we'll discuss, we're still on finance, growth, decay, and annuities. We're still going to utilize the present and future value annuities formulae, and we're going to solve problems on outstanding balance, loans, and investment. This is the end of the lesson. Thank you very much. Enjoy the rest of the day.